Today we're solving systems of linear equations by graphing. A system of linear equations is a set of two or more linear equations in the same variables. An example of a system of linear equations would be if I had two equations that both had the same variables. So here I have an equation with an x and a y, x plus y equals 6, and if I had a second equation that was 2x minus y equals 9, these two equations would be a system of linear equations. Now a solution for a system of linear equations comes in the form of an ordered pair. It's an ordered pair that is a solution of each equation in the system, so both of these equations. So in this case, my solution would be 5, 1, where 5 is my x value and 1 is my y value. If I plug them in, 5 plus 1 equals 6, and 2 times 5 is 10 minus 1 equals 9. So this is a solution for both of the equations in that system. One important thing that we want to make sure we can do when we're working with systems of linear equations is that we can check our solutions. So here we have a proposed ordered pair that is a solution of these linear equations, and we want to actually check it and make sure that it actually works. So here my solution is 2, 5. I want to make sure it actually is a solution, and for that to happen it has to work in both equations. So I'm going to plug it in for x plus y equals 7. I would have 2 plus 5 equals 7. And 2 plus 5 is 7, so it checks out. Works for the first equation. So let's try it for our second equation. 2 times 2 minus 3 times 5 equals negative 11. Well, 2 times 2 is 4, 3 times 5 is 15, so I have 4 minus 15, and 4 minus 15 is negative 11. So it also checks out for my second equation. So in this case, 2, 5 is a solution for my system of linear equations. So let's try another. Here our proposed solution is negative 2, 0. For it to be a solution for the entire system, it has to work for both equations. So let's test it out. So my y is 0 here. 0 equals negative 2 times negative 2 minus 4. Negative 2 times negative 2 is 4. And 4 minus 4 is in fact 0, so it checks out for my first equation. Let's try it for the second. 0 equals negative 2 plus 4. Negative 2 plus 4 is 2, and 2 does not equal 0. So in this case, negative 2, 0 is not a solution for my system of linear equations. It does work for one of the equations, but in order to be a solution for the system, it has to work for both. So when we're solving systems of linear equations by graphing, the solution of our system is always the point of intersection of the graphs. So we graph each equation, and where they intersect, that is our solution for the system. So in order to do this, the first thing we do is graph each equation in the same coordinate plane. They have to be in the same coordinate plane if we're going to actually see the intersection. Then we're going to estimate the point of intersection. Since we're estimating it, we always want to check the point that we estimate in step 2 by substituting for x and y for each equation of the original system, just like we substituted in when we were checking our solutions. So let's take a look at this system here. So we're being asked to solve this system by graphing. So the first thing I have to do, step 1, graph each equation in the same coordinate plane. So I'm going to start with this first equation up here. It's got a y-intercept of 5 and a slope of negative 2. So down 2 over 1, down 2 over 1, down 2 over 1, and then I'm going to connect these points. Now I'm going to graph my second equation. This one has a y-intercept of negative 1. And a slope of 4. So up 4 over 1, up 4 over 1, and I'm going to connect these guys. So my second step is to actually find the point of intersection and estimate that point. So it looks pretty obvious to me. It looks like it is 1, 3. But we always want to take that point that we found here and we want to substitute it in for x and y and actually check it in our system before we decide it's the actual solution. So let's try it with our first equation there. So our first equation was y equals negative 2x plus 5. So I'm going to substitute in 3 for y and 1 for x. So I get negative 2 plus 5, which gives me 3, and is the solution I want. So it looks like it works for my first equation. Now we're going to try the second equation. So 3 for y, 4 times 1 minus 1. So 4 times 1 is 4, minus 1 is 3, and it works out for my second equation. So my solution in this case is 1, 3. All right, so for our last example, we're going to look at a real life example. So a roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper, and his total is $1,040. In his second purchase, everything is the same price. The contractor buys 8 bundles of shingles, and it costs him $256. And they want us to find the price per bundle of shingles and the price per roll of roofing paper. So I decided X was going to be the price per bundle of shingles, and Y was going to be the price per roll of roofing paper. So in the first purchase, he made 30 of the bundles and 4 of the rolls, and it added up to $1,040. So here I just solve for Y, and I get Y equals negative 7.5x plus 260. Now this is going to be easier to graph. That's why I want it in slope-intercept form. His other purchase was just 8 bundles for $256. So I just get x equals 32, which basically means here that I have an undefined slope. When I have an x equals 32, I'm going to have a vertical line. So I've graphed my vertical line here, x equals 32. And for this one, I knew one point that was definitely on the graph was 0, 260 because it's my y-intercept. But I also plugged in 24. So I did negative 7.5 times 24 plus 260, and I got an answer of 80. So once I had 2 points, I could connect them. And this is where I found the intersection. So we're going to estimate this point right here. So it looks to be, well, we know it's at 32. Looks to be at about 32, maybe 20. So since we're estimating, we want to then check this point out by substituting it back into our equations. So let's start with our first equation. We had 30, it's going to be times 32, plus 4 times 20, and we wanted a total of 1,040. So 30 times 32 is going to give us 960. 4 times 20 is going to be 80. And if I add those two, I do in fact get 1,040 as my total. So it checks out. For my second equation, it was 8 times x is 32, equals 256. And 8 times 32 is 256. So my point checks out for both equations. So the solution here is 32, 20, which means that he bought 32 bundles of shingles. These were my shingles. And 20 rolls of, oh, I'm sorry, not 32 bundles of shingles. It's $32 per bundle of shingles and $20 per roll of roofing paper.